Hi guys, I'm going to present homework 17.2-3. The problem is there is a parking lot with 3 parking spaces, and the car enters the lot and they use one of the spaces at the main rate of 2 cars per hour. And the probability PM that exactly n space currently being used is P0, which means there are no car in the parking lot, which is zero point 0.2, and 1 is zero point 0.3, 2 is zero point 0.3, 3 is zero point 0.2. The first question is asking us to interpret this problem into a queuing system. And for a queuing system, the first attribute coming in mind is column population. And the column population for this question is supposed to be people who come to mom and pops, because the parking lot is reserved for the grocery store mom and pops customers only. And the queue is outside the parking lot, and the queue display in the real life situation, if the first car coming to the parking lot will park first, so this first come first served queue display, and the service mechanism is parallel because the customer can park at any the empty space in the parking lot, and the server is 3 available parking spaces in the parking lot, and the service time is period of time that the customer's car is parked. And for the second question is, what's the value of L, LQ, W, and WQ? For this question, L denotes the average number of cars in the parking lot with the function summation of n times Pn, where n belongs to 0 to 3. And N denotes the number of spaces that is available in the parking lot. And Pn denotes the probability of exactly n spaces are occupied, which is given in the problem. And for this question, we can just simply just plugging n and the pn into the summation function. We got 0 times p0 plus 1 times p1 plus 2 times p2 plus 3 times p3. We got 0.3 plus 0.6 plus 0.6. We got 1.5. Because this question is asking the number of cars in the number of cars, and so there's no half cars, so we just simply run that to 2. For LQ, LQ denotes the average number of cars waiting in the queue, with the function summation of n minus s times Pn, where n belongs to 0 to 3, and n denotes the number of space that is available in the parking lot, and Pn is also given. Uh, the new attribute is s. The s denotes the number of servers, so which means that the number of the parking spaces in the parking lot, which is 3. So we just simply plugging n as pn into this function. We got this equation. So we just do the calculation. We got negative 1.5. There's no negative number of cars, so we just simply run it to 0. The third one is W, and because the car entered the lot and they use one of the space at a mean rate of 2 cars per hour, so the lambda is 2. Then by the formula, W equals L divided by lambda, we get the average waiting time of W is 1 hour, because the L we could just calculate before is 2 here, so we just is 2 divided by 2, which is 1 hour. And for the WQ, which is asking the average waiting time in the queue, is given by the formula LQ divided by lambda. And LQ is 0 here, so we just 0 divided by 2 is 0 hour, 0 minutes. And the last question is, what's the average length of time that a car remains in the parking space? So for this one, we just use uh the W minus WQ, which is 60 minus 0, which is 60. The 60 is come to 1 hour, comes from 1 hour. 1 hour is 60 minutes, so I use 60 minutes minus 0, which is 60 minutes, and that's it. Thank you.